So now let's start our standalone installation of Microsoft Visual Studio Code IDE. We can install Visual Studio in two ways. One of the ways is the one we are going to install now, which is a standalone installation. And by standalone, I mean a completely independent installation from any other platform, specifically independent from Anaconda. So this installation we're going to install has nothing to do with Anaconda, and later when we install Anaconda we will see that it already comes with an inbuilt Visual Studio Code installation inside it. So one thing is using Visual Studio Code outside Anaconda, and another thing is using Python virtual environments together with Anaconda. So how to install Visual Studio Code independent from Anaconda or independent from any virtual environments. So as you know, we have two major application installation managers in Linux. One is the apt and the other is Snap. And if we look for Visual Studio Code application name in Linux, which is code, and search for it as using sudo apt list code or star code star, we'll actually not find it. We have some other applications here that include the word code, but none of them are Visual Studio Code. Why? Because Visual Studio Code is not available at the default Linux installation servers, and therefore is not available at apt, at least by default. So, and what about Snap? Snap servers actually are not the same servers we have installed at Linux configuration installation servers. Snap actually has its own installation server. So if you look the same code application, for example using sudo snap find encode, which is the name that I already know, the name that Visual Studio Code is known in Linux, it will actually find it. And here it is, the code application available for installation through the Snap server, which I repeat is separate from the servers from apt. So we can simply use snap sudo snap install and the name of the application, which is code. So that's as simple as it is. For installing the Visual Studio Code, the standalone Visual Studio Code installation, you simply have to use snap install and the name of the application, which is code. In case you do not have Snap installed in your system, for example, if we look sudo apt list snap star, you see that Snap is available for installation through the apt application manager. And through apt you can actually install Snap if you do not have it yet installed, and you can see if it's installed by simply typing snap version. If something appears, it's because Snap is available and installed, and if it's not, you can simply install it by using sudo apt. apt is installed by default in any Linux Ubuntu installation, so you can simply use the apt for installing Snap by using sudo apt install snap. So it will install Snap, and then you can use Snap for installing Visual Studio Code by using sudo snap install code. So this is the only command line you gotta need for installing the standalone installation of Visual Studio Code in your Linux Ubuntu. So let's press enter. This revision of Snap code was published using classic confinement and thus may perform arbitrary system changes outside of the security sandbox that snaps are usually confined to. which may put your system at risk. So don't mind that. You can simply proceed by using sudo snap install code and using the attribute classic, and it will download the most recent stable version of Visual Studio Code from the Snap servers. And I will fast forward this for you not have to lose your time waiting this. Okay, Snap has finished installing the Visual Studio Code version available at Snap servers, and we can check that by simply using snap list, and differently from apt, the list subcommand here of Snap will not show all available applications on the available servers. It will show only the already installed applications and only the ones installed using Snap, which is the case of Visual Studio Code we've just installed. So you can use snap list and it will show all the applications installed in my machine that I have installed through Snap, including the code application, which is the name for Visual Studio Code from Microsoft. The latest stable version, which is this version here, which is the latest one available at the Snap servers. Another way to see if the installation has succeeded is by calling code, which is the application name, along with version, and if it has been correctly installed, it will show the version number of the application, which in this case is 1.92.1, which proves that the application is actually installed. And for opening the application, we can simply call code, and it will open Visual Studio Code, the graphical user interface of the application, so that we can use it. And if you see here, Snap has already added the icon or the shortcut, so that if you want to open the Visual Studio Code application, you can either click on the symbolic link icon here, created by Snap itself, and set it here at the favorite desktop bar, or you can open it through the terminal by using the code command name for the application. But before we open Visual Studio Code and test it, let me show you where the Snap Application Installation Manager actually installs any application when using Snap. So if you go here to the root folder, you see there's a Snap folder here. So if you open, you see all the folders for every Snap application installed at my machine. And you see here that we have a code folder, so root/snap/code, and at this root/snap/bin folder, you have symbolic links for every one of those applications installed using Snap, including the code symbolic link. So we have this symbolic link code that links to the executable file at the code folder, so that we can simply click at it, or we can actually, if we see for example the environment path variable, we see that the snap bin folder where we saw all those symbolic links to each one of these Snap applications installed is actually added when Snap is installed to our path variable. So all of those symbolic links you can call without having to specify the whole path. For example, we can simply call the code symbolic link, and it will call that symbolic link at snap/bin, which in turn will call the executable file at the /snap/code folder. So that's why we can either open Visual Studio Code using the symbolic link code from anywhere at our file system, or we can simply click on the symbolic link desktop icon here at the favorite bar. So let's open Visual Studio Code. So here is the same Visual Studio Code that you will have either on Windows or Mac OS. You have here at Linux. So here, as we open Visual Studio Code, it starts by asking if I want to install some recommended extensions, for example, Docker extension. For now, we won't be using Docker, so I don't need this extension at the moment. But if you go here at the Extensions tab, you see some other useful extensions, including the Python extension. You can search for it and click at it. And in case it doesn't appear as installed, in my case it's already installed, I'll actually uninstall it. Okay, so now it appears as uninstalled, and it asks if you want to install. You can click here, install release version for the latest release. In case you want the beta version, there's this other option here, but I'll install the latest release one. So as you click there, it simply installs, and now you can use Python features when creating any Python file. And of course there are other many plugins or extensions. For example, JupyterNotebook extension, which in my case I have also installed here. You can install that too. And some other extensions not yet installed here at my Visual Studio Code installation. For example, Docker extension, Kubernetes, and so on. So we have our first integrated development environment installed, Visual Studio Code from Microsoft. And as you install the base installation of VS Code, you then can install additional plugins or extensions according to the languages or dependencies you wanna make use. So instead of installing hundreds of dependencies at once, you only install here through the extensions the ones you'll be using. In our case, we're using only Python, so we gotta install the Python extension and eventually also the JupyterNotebook extension. You'll see more of JupyterNotebook when we install Anaconda, but here at our standalone installation of Visual Studio Code, you also can use JupyterNotebook if you wish. We'll not do that. We'll simply now use the Python extension. So, and for creating a Python program using Visual Studio Code, how do we do? Very simple, just use here file, new file, Python file, and as you see, it will already recognize your text file here, which is a Python file you've just selected as a Python program. So if you see this symbol here of Python, you already know that Visual Studio Code is recognizing that the code you'll be writing will be a Python code. And not only that, but it will also turn available the autocomplete. For example, for showing the possible functions you may use and the associated documentation for those. For example, for the print function, you can simply look here and you will easily see the definition of that function with the return, with the attributes possible that you can pass as arguments inside the parentheses of the function, and all that. We'll see everything when we actually start seeing the Python syntax, but just advancing a little bit here at the documentation here at Visual Studio Code, it already shows you the definition of the print function, for example, with each of the parameters, for example, the values, the sep, separator, the end, the file, the flush, and here down below it shows what each one of those are. Although a short description, it may be useful if you just wanna remember what each parameter is. So in our case, we'll simply use the print function along with a string. So the string here will be taken as the values parameter or the values argument. We'll simply use hello world Python. Okay, and for running it, first we gotta save it. We can press Ctrl S or File and Save. But first we should actually create a workspace folder. For example, here at our home folder, we can simply create here a folder, a new folder called VS Code -workspace, so that now we can save this program we are creating inside it. So we can go here now, VS Code workspace. We should actually create another folder here for our project. You can do that at your file system manager or here directly create another folder. The name of the folder, I'll call it test. So now we are saving it inside my home / VS Code workspace / test folder. And the name of the file or the name of the program, simply call it test again, test.py, and save it. So now it's saved, as you can see here, test.py. And here is the path, complete path, home /Daniel /VS Code workspace /test and the file name here, test.py. So every time you use the py or py extension in a text file, VS Code will automatically identify that as a Python program. So that's one of the advantages of using extensions even in Linux, although Linux does not actually depend on extensions, but some of the programs, for example Visual Studio Code, might benefit from extensions, for example for identifying the code files as Python files or Java files or JavaScript files or whatever according to the extension. So always save your Python files inside which you put your code as a py extension file. And now for running it, we can simply use here the run icon for run Python file or run Python file in dedicated terminal, or there's actually this other option here, run current file in interactive window. And for this interactive window, you gotta have Jupyter Notebook installed, because the interaction here is basically running this Python snippet of code or Python code along with Jupyter Notebook and the HTML that's associated with Python on Jupyter Notebook output, so that you have a more interactive display. And we'll see it better when we install Anaconda. But in case you want to use this option here, interactive window, you gotta install that plugin that I have actually showed you initially, which is the Jupyter Notebook plugin or extension. So you just gotta install that and it will also be available, this option here, for showing the output of the Python code in a Jupyter Notebook output window. So, but let's just show this option here, run Python file, and it will show the output, which is basically the string message here, hello world Python. There's also the debugger for Python. If you want to debug your code, we'll also not doing that for now. So basically what we wanted to do was accomplish it, which was to install the Visual Studio Code, the standalone installation of it using Snap, and then write our first Python program using Visual Studio Code and running it here inside Visual Studio Code at its own terminal, which is independent from the Linux terminal actually. Okay, so you can close this. You can also close the integrated terminal here. If you wanna open the project folder, you just gotta click here and go to VS Code workspace and the folder of the project we are dealing with. So it's the test folder here, and when you open, it will show all the files inside that folder identified, for example the Python files and some other dependency files, for example image files or HTML files and so on. So it will show all the content of the folder of your project here. You can also create additional folders inside this test folder that you've opened. You can create additional files and so on. So this is the basic use of Visual Studio Code with Python, and we'll see a lot of other examples later. You can go here to configurations also, and for example at settings you can see a lot of settings configurations regarding the text editor, the workbench, the window, features, application, security, and the extensions. For example, the extension for Python, if you go here, you can set the default interpreter path. We have the symbolic link Python and Python 3 at our machine. The Python is now set to call the Python 3.13 version, and Python 3 is set to call the standard Python 3.10. So in our case, the version that Visual Studio Code is using is the version associated to this symbolic link Python, which actually is the version Python 3.13. So if we wanted to by default set the other symbolic link to be called here from Visual Studio Code, we could, for example, use Python 3, but I'll leave that as Python so that I can simply change the Python symbolic link alternative whenever I want and use the other versions of Python configured at the alternative instead. So you don't have to change anything here. I'm just showing you where the configurations are available, and there's a lot of them. For example, let's increase the font size to 20. You don't have to save, it's automatically saved when you get out of the field. You can see here it's already saved, and the font size has actually increased. So that's basically it. Observe here that it will always create this hidden folder .vs code with some configurations for the current project, And later we'll see how to put this as an exception for not sending it to your project repository at GitHub.